Okay, let's look at problem 23. Now 23 says 3 tan cubed x equals tan of x. So we'll write this as 3 tan cubed x minus tan of x equals 0. Now if we go back to the algebraic equivalent from last year, this would have been 3y cubed equals y cubed. Y rather, not y cubed. And we would write this as 3y cubed minus y equals 0. Factoring the y out, we get y times 3y squared minus 1 equals 0. Using the cases again, case 1 becomes y equals 0. Case 2 becomes 3y squared minus 1 equals 0. So 3y squared equals 1. So y squared is 1 divided by 3. And y would be 1 plus or minus 1 over the square root of 3. Now let's apply the same thing to the trigonometric values here. Factor tan of x out, and you're left with 3 tan square x minus 1 equals 0. Case 1, you have tan of x equals 0. Now the tan of x can be written as the sine of x divided by the cosine of x. Now the only time that's going to be 0 is when the sine of x is 0. And that will occur when x is equal to 0 or pi. Now let's go to case 2. Now case 2 is going to be 3 tan square x. Should be just square. Let me drop it into that. 3 tan square x equals 1. So tan square x equals 1/3. Taking the square root of each side, this would be plus or minus 1 over the square root of 3. Now when does that happen? Well, that's going to happen 4 times going around the unit circle. First time it happens will be at pi over 6. At pi over 6, the sine is 1/2. The cosine is square root of 3 over 2, so that's 1 over the square root of 3. It will also happen at 5 pi over 6. That would give us the negative 1 over the square root of 3. At 7 pi over 6, that would be a negative sine and a negative cosine, so we have a positive 1 over the square root of 3. And at 11 pi over 6, that would give us the negative 1 over the square root of 3. So in this case, we have 6 solutions. And those solutions are going to be 0, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now again, check this on your unit circle. The unit circle is incorporated into these solutions, and again, you're not going to get something over here where you only have 3 solutions. We've got twice as many over here. Okay,